Okay, so this video is over Kinemax 1B and it's going to be about acceleration, the concept of acceleration and then solving problems with constant acceleration equations. As always, you should take notes over this section. After you watch this video, you're going to work on a practice worksheet and then take a quiz over this section. So in the last video we talked about different units like meters per second for velocity, meters per second squared for acceleration. We talked about constant velocity problems, which have a very easy equation, just d equals v times t. And then we talked about constant speed problems. Now we're going to introduce the concept of acceleration. Remember, there's two main types of motion that you're going to see in this whole physics course. You're going to see constant velocity problems, and you're going to see constant acceleration problems. So when objects are not moving at a constant velocity, typically it's because either they're moving faster, they're speeding up, or they're moving slower, they're slowing down. If an object changes its velocity, that means it is accelerating. So objects that change their velocity are said to have acceleration. Now, the symbol that we're going to use for acceleration is going to be a lowercase a. Okay, so just like we use a lowercase t for time and a lowercase v for velocity, we're going to use a lowercase a for acceleration. And this is the definition of acceleration. Acceleration is defined as the rate that velocity of an object changes over time. Okay, so it's a rate of change. Okay, the rate that which acceleration is defined as the rate that velocity of an object changes over time. The unit for acceleration is meters per second squared, or you might think of it as meters per second per second. So what does that mean? Now it's really important that you understand the concept of acceleration, because we're going to be dealing with acceleration a lot later on, and you have to understand the difference between velocity and acceleration. So here it is. Velocity has to do with how fast an object is moving. How fast an object is moving and in what direction. Okay, if you have a positive velocity, you're moving in the positive direction. If you have a negative velocity, you're moving in the negative direction. Okay, acceleration has nothing to do with how fast an object is moving. Okay, acceleration has to do with how quickly velocity is changing. That has nothing to do with how fast it's actually moving. So we're going to do two concept examples before we do any problem solving with acceleration, because it's really important that you understand what acceleration is. Okay, so here's a concept example. Let's say we have an object, and it says an object starting at rest. By the way, anytime you ever see this always means that the initial velocity or the starting velocity of the object is 0. Okay, if it starts at rest, that means it starts off not moving. So this example says an object starting at rest has an acceleration of 2 meters per second squared. Make sure you say that correctly, meters per second squared. By the way, nothing else in physics has units of meters per second squared except for acceleration. So anytime you see that unit, meters per second squared, you instantly know that is acceleration. So an object starting at rest has an acceleration of 2 meters per second squared. Its velocity over time is shown to the right. Now, if you look at this table, at time 0 seconds, that means at the beginning of the problem, the velocity of the object is 0 meters per second, which makes sense because it says it starts at rest. Now, I want to tell you what this 2 meters per second squared means. That means after 1 second of time has passed, the object now has a velocity of 2 meters per second. After 2 seconds have passed, the object now has a velocity of 4 meters per second. After 3 seconds have passed, the object now has a velocity of 6 meters per second. So in other words, if the acceleration is 2 meters per second squared, that has nothing to do with how fast the object is moving. That just means that the velocity itself is changing by 2 meters per second every second. Okay, so 2 meters per second squared, you can think of that as 2 meters per second per second. The velocity is changing by that number every second. Okay, so you can see over here, after 6 seconds have passed, the velocity is now 12 meters per second. So this object is basically starting off not moving, and it's speeding up, and it's speeding up in the positive direction. Okay, but this acceleration has nothing to do with how fast it's moving. It's just telling us how fast the velocity is changing per second. Okay, so let's do one more concept example. Okay, this says an object starting with an initial velocity of 4 meters per second has an acceleration of -1 meters per second squared. Its velocity over time is shown to the right. So at time t equals 0 seconds right here, the velocity of the object is 4 meters per second. That's what it tells us right here when it says the initial velocity is 4 meters per second. Now if the acceleration is -1 meters per second squared, that means every 1 second that passes, the velocity changes by -1. Okay, so if it starts at 4 meters per second, after 1 second has passed, the velocity is now 3 meters per second. At t equals 2 seconds, the velocity is now 2 meters per second. After 3 seconds, it's now 1 meter per second. Notice that at t equals 4 seconds, the velocity is 0. In other words, the object stops moving. So if you look during the first 4 seconds, the object starts off with a velocity of 4 meters per second, and it's slowing down because the velocity goes from 4 to 3 to 2 to 1 to 0, and it stops. Now, at 5 seconds, the velocity is now -1 meter per second, because remember, the acceleration is -1, meaning the velocity changes by that number each second. So what does that mean, -1 meters per second? Well, that means that the object is now moving in the negative direction. And if you just look at the numbers now, 0, 1, 2, now the object is starting to speed up in the negative direction, because it stops right here at 4 seconds, and then it's going 1 meter per second in the negative direction, and then 2 meters per second in the negative direction, and at 7 seconds it would be 3 meters per second in the negative direction, and so on. So hopefully that helps you understand the concept of what acceleration is. Okay, now we can look at the moving man really quickly just to see what that might look like. So I'm going to put this guy back here with no velocity, and I'm going to give him an acceleration of 1 meter per second. Okay, and if you watch him, you'll see he speeds up. He goes faster and faster and faster and faster, and then he hits the wall and he stops. Now, let me show you the situation we had a second ago, where he had a velocity of 4 meters per second at the beginning. Oops, let me pause that. So he has a velocity of 4 meters per second initially, and an acceleration of -1 meter per second squared. Now watch what happens when I hit play. He slows down, he slows down, he slows down, he stops, and then he turns around and speeds up again. So that's basically the situation that we just saw in the table. Okay, so hopefully that helps you understand the concept of acceleration a little bit more. Example 0.5. We're going to skip this example. It kind of goes in line with the 2 examples that we just did before. Actually, we can do it really quickly. A ball rolls down a hill starting from rest. As you go through these problems, always look for these context clues. From rest means that the initial velocity of the object is 0. Now, I'm going to label that VI. VI means initial velocity. That's how fast it's moving at the beginning of the problem. VI equals 0. It has an acceleration of 0.5 meters per second squared. I'm going to label that with an A for acceleration. Now it tells me it's acceleration, but it also can tell, looking at the unit meter per second squared, that has to be acceleration. How fast is always a question about velocity. Okay, and I'm going to label this VF for final velocity. Now you might ask, how do I know it's final velocity? Well, because I'm given the initial velocity is 0 in the problem. So I want to know how fast is the ball moving after 4 seconds. And so this, you don't need an equation to actually answer this, although you could use one. This is basically a concept problem, seeing if you understand the concept of acceleration. So if you start off with a velocity of 0 and you increase by 0.5 meters per second every second, that means after 1 second has passed, the velocity of the ball is 0.5 meters per second. Okay, so I'm going to make a little chart here. So at 0 seconds, so this is going to be my time, this is going to be my velocity. After 1 second, the velocity is 0.5 meters per second. At 2 seconds, it's going to be 1. At 3 seconds, it's going to be 1.5. It's increasing by 0.5 meters per second. And at 4 seconds, that's going to be 2 meters per second. Okay, so just a really simple concept problem involving acceleration. Now, let's get to the harder stuff. Okay, solving problems using constant acceleration equations. Okay, now there's one equation for constant velocity, d equals v times t. Because constant acceleration is more complicated, there's actually 3 different equations for constant acceleration. Okay, here are the 3 equations down below. Please add these to your notes because you're going to be using these equations a lot to solve problems. Let's go through them one at a time. Vf represents the final velocity of an object. That is, what is the velocity of the object at the end of the problem. Vi represents the initial velocity of the object, how fast it's moving at the beginning of the problem. A represents acceleration in meters per second squared. T represents time in seconds. And now we have this d with a subscript x. dx is what we're going to write for displacement. Okay, now the reason there's an x there is because all the problems we're doing for now are only moving side to side. In the next section, we'll talk about what happens when problems have falling objects. So the dx, the x just means objects are moving side to side horizontally. Okay, and again, dx, it's not d times x. dx is all one symbol representing the displacement of the object. Okay, by the way, in this equation right here, it's vf squared vi squared plus 2 times a times dx. In this equation down here, we have dx equals vi times t plus 1/2 times a times t squared, and only the t is being squared in this equation. So as you're solving problems with these equations, it's really important that you identify all of the variables that you're given. You identify what you're solving for, and then you plug into the equation and rearrange and solve for what you're asked to find. So we're going to do some examples, and then you're going to work on your practice worksheet. And please let me know if you have any questions. Once you do enough of these problems, they should be pretty simple. The hardest part is identifying what's given in the problem. That's why it's really important that you understand the units of everything. So let's do some examples. Okay, example 1. A car sitting at rest in front of a red light accelerates at a rate of 0.25 meters per second squared. Now, the first thing I see is the car is sitting at rest. Okay, that means at the beginning of the problem, the car is not moving. So that means the initial velocity of the car, I'm going to label that as 0 meters per second. Okay, that is a context clue. So it accelerates at a rate of 0.25 meters per second squared. I look at this number and I look at the unit, meters per second squared. The only thing that has units of meters per second squared has to be acceleration. So I label this as A. So the light turns green. I'm asked to calculate the velocity. Now the equations have 2 velocities in them, but because we already have the initial velocity, that means this problem is asking me for the final velocity. That is my unknown. That's what I'm being asked to calculate. And I'm also given a time of 12 seconds. Now the question I always get is, how do I know what equation to use? Okay, here's the thing about these problems. There's 4 things in each of the 3 equations. Okay, 3 of them should be given. 1 of them should be unknown. So in this case, we have Vi, A, and T are my 3 givens, and I have 1 unknown. That's Vf. Listen carefully. There is only 1 equation that has those 4 things in it. Okay, so the answer to the question, how do you know which equation to use? You only use the equation that has those exact 4 things in it. Okay. In other words, if you look at the 4 things I underlined here, you don't see anything with meters or displacement anywhere in the problem. That means I need to use the equation that does not have displacement in it, because that's not one of my givens or my unknown. So I'm going to use the equation that looks like this. Vf equals Vi plus A times T. I choose my equation. I'm going to plug in. Vf I'm going to leave there because that's my unknown. I don't know what that is. Vi is 0 plus A, the acceleration was 0.25 times T, the time is 12 seconds. So Vf equals 0. I'm not even going to write the 0 because it doesn't matter. I'm just adding it to this number over here. So 0 plus 0.25 times 12 is going to be 3, and that's going to be 3 meters per second because velocity is measured in meters per second. Okay, and so that is the answer to example 1. Pause it there if you need to look over that. Okay, let's take a look at another example. A truck driving down the highway takes 12 seconds to accelerate from 12 meters per second to 36 meters per second. So I'm always looking at numbers and I'm always looking at units. 12 seconds is a time. Okay, I know based off the units. And it says to accelerate from 12 meters per second to 36 meters per second. Now meters per second is velocity, and so these are both velocities. Now I have two velocities in my equations. I have initial velocity and I have final velocity. The 12 meters per second is going to be my initial velocity because it says I'm going from 12 meters per second to 36 meters per second. So I'm going to end up at 36 meters per second. So the truck is speeding up over 12 seconds. And I'm asked to find the acceleration of the truck. That is my unknown. Now again, how do you know which equation to use? You always have to do this step first, guys. You have to find your 3 givens and your 1 unknown. If you don't do that, then you're going to get stuck. You have to have those 4 things before you choose the equation. There's no way to solve the problem if you don't have these 4 things. Now that I have my 4 things, I have VI, VF, T, and A, I choose the only equation that has those exact 4 things. Okay, and that's going to be the same equation that we used before. VF equals VI plus A times T. I choose my equation. I'm going to plug in. For VF, I have 36. For VI, I have 12 plus A. I don't know what A is. A was my unknown. That's what I'm solving for, and so I'm going to leave that alone. I have A times T, and T was 12. And so now I have basically an algebra problem where I have to rearrange this equation and get A by itself. So I have 36 equals 12 plus A times 12. I want to get A by itself. What I'm going to do is I'm basically going to do PEMDAS backwards. So PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. That's the order of operations that you learned in middle school. Now to get A by itself, I'm basically going to do PEMDAS backwards. And so that means the first thing I'm going to do is I'm going to subtract 12 on both sides. Now the reason you do it on both sides is because in algebra you can basically do anything you want as long as you do it equally to both sides. So if I do minus 12 here to get rid of this 12, I have to do minus 12 here as well. So 12 minus 12 is going to cancel. 36 minus 12 is going to equal 24. And I still have this A times 12 on the right side. I look here, I say A, what's happening to A? A is being multiplied by 12. I want to get A by itself, so I want to undo that multiplication. The opposite of multiply is divide. Instead of I'm multiplying by 12, I need to divide by 12, but I need to do it equally on both sides. Okay, so divide by 12, divide by 12. So A is going to equal 24 divided by 12, which is 2 meters per second squared. And so you see these problems are a little more involved than constant velocity problems. There's a little bit more math involved, and you have to be careful identifying your variables. Pause it here if you need to look over that more carefully. Okay, so let's go to the next example. Example 3. A boy running a 40-meter race accelerates from rest. Again, as I'm reading these problems for the first time, I'm always looking for numbers and I'm looking for context clues. Okay, 40-meter race. What is measured in meters? Well, that is displacement, so I'm going to label that dx. Okay, that's the only thing that's measured in meters is distance and displacement. Accelerates from rest. We've seen that context clue before, right? If you start off from rest, that means at the beginning of the problem you're not moving. Okay, that means your initial velocity is 0 meters per second. I see this number 0.3 meters per second squared. You might not know what that is right away, but again, this is why it's so important that you understand units. If you look at the unit meter per second squared, what has units of meter per second squared? That has to be acceleration. Okay, so 0.3 meters per second squared is going to be acceleration until he finishes the race. Calculate the velocity of the boy by the end of the race. Okay, so I'm looking for the velocity. It tells me to calculate the velocity. I already have the initial velocity because it's given to me when it says it starts from rest. So my unknown is going to be VF. Guys, you have to do this step first. This is the most important step, is finding your three givens and your unknown. Okay, so you should have four things. I have dx, vi, a, and v final. Okay, I need to choose from my list of three equations. I need to choose the equation that has those exact four things. That's the only equation I'm allowed to use. Okay, so the equation that has those four things looks like this. Vf squared equals vi squared plus 2 times a times dx. Okay, so I choose my equation, and now I'm going to substitute. That means I'm going to plug in, and I'm going to solve. I don't know v final, so I'm just going to leave that as vf squared. That's my unknown. Vi squared, I know that vi, because it starts from rest, is 0. Plus 2 times a. I found the acceleration is 0.3. And then dx, if it's a 40-meter race, that is my displacement, so that's going to be 40 meters. Okay, now I have vf squared here, and so I am going to have to do a square root here in a minute. But first, let me just clean this up. Vf squared equals 0 squared, which is just 0. So I'm not even going to bother writing this 0 squared down because it doesn't really matter. So Vf squared is basically just equal to 2 times 0.3 times 40. Okay, now if I just multiply these numbers, I get 24. Okay, however, this is solved for Vf squared, and I want Vf. Okay, so I need to do the opposite square, which is square root. So I do the square root on both sides, and I find that V final is equal to the square root of 24, which is 4.9 meters per second. Okay, so that is example 3. Okay, so pause it there if you need to look over that some more. Okay, so we've now done 3 examples. You're now going to work on a practice worksheet. As always, please let me know if you have any questions. After you finish the practice worksheet, if you miss any, you're welcome to redo the practice worksheet until you get 100% correct. If you have any questions, please let me know by email or on Zoom. And as always, guys, I'll see you in the next video.